Hello, everyone. In this section, we will learn how to perform conditional processing in assembly language. The topics we will cover are first, how comparison instructions create Boolean results. Second, how to perform conditional jumps and loops. Third, how to use conditional processing to mimic conventional if and while branching. And finally, we will look at the .repeat and .while directives. Let's begin with how comparison instructions create Boolean results. Assembly uses comparison instructions like CMP and test to set status flags in the CPU based on a Boolean or true-false result. The CMP instruction, with two operands, performs a subtraction of the second operand from the first and sets the flags, such as the zero flag and the sign flag, based on the result. It does not store the result of the subtraction, it only changes the flags. The test instruction performs a bitwise AND operation on its two operands and sets the flags. This is commonly used to check if a value is 0 or negative. Let's look at an example of the CMP instruction in NASM for x86-64 Linux. This program will compare two integers and print whether the first is greater than, less than, or equal to the second. First, we install the necessary tools, NASM and GCC. Then, we write our assembly code. In the data section, we define three messages: equal, greater, and less, each followed by a new line character. We also calculate their lengths. In the text section, we have our main code, MOVE AX, 5, MOVEBX, 10, CMPEAX, EBX. This compares 5 and 10. JE equal. This jumps to the equal label if the values are equal. JG greater. This jumps to the greater label if the first value is greater. If neither of those jumps is taken, it means the first value is less, so the code continues to the lesses block. The less block uses a system call to print the less message and then jumps to the done label. The greater block prints the greater message and jumps to done. The equal block prints the equal message. The done label contains the code to exit the program. After writing the code to a file, we assemble it with NASM and link it with LD. When we run the program, it will print less because 5 is less than 10. Next, let's see how to perform conditional jumps and loops. In assembly, conditional jumps allow you to make decisions and create loops, just like if, while, or for statements in high-level languages. Here are some common conditional jump instructions for x86. JE or JZ jumps if the last comparison was equal or if the result was 0. JNE or JNZ jumps if not equal or not 0. JG or JNLE jumps if greater. JL or JNGE jumps if less. JGE jumps if greater or equal. JLE jumps if less or equal. You can create loops by jumping back to a label. A common way to do this is with the loop instruction, which uses the ECX register as a counter. For example, MOVECX, 5, loop start. Some instructions: loop loop start. This decrements ECX and jumps back to loop start if ECX is not 0. Let's look at an example of a countdown loop in NASM. This program will print a countdown from 5 to 1. First, we install the tools. Then, we write the assembly code. In the data section, we define a string of numbers: 5, 4, 3, 2, 1, each followed by a new line character. In the text section, our code starts by pointing the RSI register to the beginning of our number string and setting the loop counter RC x to 5. The print loop label contains the system call to write 2 bytes, which is 1 digit and a new line, to the screen. Add RSI, comma, 2 moves the pointer to the next number in the string. Print loop decrements RCX and jumps back to the beginning of the loop. If RCX is not 0, after the loop finishes, the program exits. When we assemble, link, and run this code, it will print the numbers 5 through 1 on separate lines. What we learned here is that the loop instruction uses RCX as a counter. JMP is an unconditional jump, and conditional jumps like JE, JNE, and JG use the results of a CMP instruction to decide whether to jump. Now, let's see how to use conditional processing to mimic if and while branching. In high-level languages, we use if statements and while loops. In assembly, we can mimic these using CMP followed by conditional jumps. To mimic an if statement, like if EAX is greater than 10, we would write CMPEAX, 10, JLE skip. This means if EAX is less than or equal to 10, we jump over the if block. The code for when EAX is greater than 10 goes here. I skip. This is the label we jump to. To mimic a while loop, like while ECX is greater than 0, we would write loop start, CMPECX, 0, JLE loop end. This exits the loop if ECX is less than or equal to 0. The code inside the loop goes here. DECECX, JMP loop start, loop end. Let's look at an example that simulates both an if and a while loop. First, we install the tools. Then, we write the code. In the data section, we have a message inside loop. In the text section, we start by setting ECX to 3. This will be our while loop counter. The loop start label begins our while loop. We check if ECX is 0 or less, and if so, we jump to loop end. Inside the loop, we have a simulated if statement. We check if ECX is equal to 2. If it is, we jump to skip print. If ECX is not 2, we print our message. The skip print label is where we land if we skip the printing. Then we decrement ECX prime and jump back to the start of the loop. The loop end label contains the code to exit the program. When we run this code, it will print inside loop 2 times for when ECX is 3 and 1, but not for when it is 2. What we learned here is that you can simulate an if statement with a CMP and a jump over a block of code. You can simulate a while loop with a label at the start and a conditional jump to an end label. Finally, let's discuss the .repeat and .while directives. These are features of some assemblers like MASM, the Microsoft Macro Assembler. They are not available in NASM, which we are using. They are pseudo high-level directives that make the code look more like a high-level language. They are not actual CPU instructions, but macros that the assembler translates into real assembly instructions. For example, a .repeat until loop in MASM might look like this: MOVCX, 5, .repeat. Some code, DECCX, .UNTILCX = 0. The assembler would translate this into a label, the code block, a decrement, a compare instruction, and a conditional jump. Similarly, a .while loop in MASM, MOVCX, 5, .whilecx not equal to 0. Some code, DECCX, .endw for end while. This would be translated into a starting label with a compare and a conditional jump to the end, the code block, a decrement, and an unconditional jump back to the start. The key points are that these directives are shortcuts that the assembler expands into actual instructions. They are not supported by NASM. You might see them in tutorials for Windows assembly programming. Let's have a quick summary of this section. We learned that comparison instructions like CMP and TEST create Boolean results by setting the CPU flags. Conditional jumps like JE and JG use these flags to decide whether to jump to a different part of the program. We can create loops using labels and jump instructions or with the loop instruction. We can mimic if and while structures from high-level languages using a combination of CMP and conditional jumps. And finally, some assemblers like MASM provide high-level directives like .repeat and .while, but NASM does not. This concludes our lesson on how to perform conditional processing. Thank you.